All right. So, last time we had started with time and work, and we solved few questions of time and work. We had not completed the entire PPT, but we had solved majority of the questions. Okay. So, pipe A can fill the tank in 4 hours, and pipe B can empty the tank in 3 hours. So our step one is always to assume work, and work should ideally be a multiple of the numbers given to me over here, which are 4 and 3. So what is the work that you can assume? Multiple
12.
of 4 and 3, 12. So I will assume that the capacity of the tank is 12 liters. Okay. Now, second step is to find the efficiency of both the pipes. If pipe A can fill the entire 12 liters in 4 hours, how much must A be filling per hour? 3 liters per hour. And similarly, if pipe B can empty the entire 12 liters in 3 hours, how much can B empty in 1 hour?
4 liters.
4 per hour. So this is the efficiency of pipe A and pipe B. Okay, all right. Now what is asked? If they opened on alternate hours starting with B. So first B opened, then A opened, then B opened, then A opened, and it went on. Then how much time in hours will they take to empty the full tank? So in the first 1 hour, B will be emptying 4 liters. In the second hour, A will be filling 3 liters. In the third hour, B will be emptying 4 liters, then filling 3 liters, and it will go on like this. Are you understanding this, Rachel?
Yes, ma'am.
Okay, which means in the first 2 hours, they are emptying 1 liter. Similarly, in the next 2 hours, they are emptying 1 liter, and this pattern will go on. So basically, if they are emptying 1 liter every 2 hours, to empty 12 liters, ideally you will say the answer would be 24 hours. But because here I have a combination of plus and minus, I cannot go directly like that. Out of 4 and 3, the bigger magnitude is 4. So I will stop. I mean, I will go with this pattern, but only till 8 liters. So what I will do is, I will go up till emptying 8 liters. So to empty 8 liters, I know I will need 16 hours. Okay, now what happens after that is, once I've emptied 8 liters, now it is B's chance. So now B will be emptying 4 liters in the other go, and which is why 12 liters will be emptied in the next 1 hour. And that is why your answer is going to be 17 hours and not 24 hours. I hope till this pattern it is clear. Now, why did we not do it directly? Because it is a combination of plus minus. So you do this directly only up till 8 liters, which will take 16 hours. After that, you go hour by hour. So after 16 hours, in the 17th hour, we will empty 4 more liters, which will result into emptying 8 plus 4, 12 liters. And that is why at that one point, your tank will be completely empty. Your answer is 17 hours. Are we getting this, Rachel?
Yes, ma'am.
All right, then let's move ahead. Aryan alone can do a job in 10 days, whereas Piyush alone can do a job in 20 days. So Aryan can do a job in 10 days, and Piyush can do a job in 20 days. Aryan starts the job, okay, and after 3 days, Piyush joins him. So Aryan works for 3 days alone, and then Piyush joins him. Okay, so then they are working together, and again after few more days, we don't know how many days, but Bimal joins them, and then they all three finish the work together. Did you understand this diagram, both of you?
Yes, ma'am.
Okay, now it is said that if Bimal has done 10% of the job, which means Aryan and Piyush must have done the remaining 90% of the job. In how many days is the job done? Okay, so what will we do? First thing, step one,
Assume work.
assume work. So, what is the work that you want to assume?
100.
100? That's fine, let's assume 100. So, which means your work is to pack 100 boxes. Okay, so what is the efficiency of A?
10 per day.
10 per day, and efficiency of B would be
5 per day.
5 per day. I hope both of you are with me up till here. Now, Aryan is working for 3 days alone. So, in these 3 days, Aryan will be packing how many boxes?
30.
Correct? 10 here, 10 here, and 10 here. So, 30 boxes are packed. Now, I don't know how many days they work together, but I know one thing, that Bimal does only 10% of the job. 10% of 100?
10.
10. Which means Bimal is packing only 10 boxes alone. So now how many
Yes.
boxes are left to be packed? 10, 10,
60.
10, and 10. 40 are done. 60 are left. Now for these 60 boxes, Aryan is packing 10 per day and Piyush is packing 5 per day, which means they both together are packing 15 per day. So how many days are required to pack these 16 boxes? we we'll have to do it again. I'll quickly go through it again. So Aryan can do a piece of work in 10 days and Piyush can do a piece of work in 20 days is given to us. Now Aryan starts the job and 3 days later Piyush joins him. If I have to kind of draw a timeline over here, Aryan starts working, works for 3 days alone. Then Piyush joins him and they both start working together. And after few more days, Bimal joins. We don't know how many days. Okay. And he does 10% of the job, which means if Bimal is doing 10% of the job, the remaining 90% of the job is done by Aryan and Piyush. Correct?
Yes, ma'am.
Okay. So first let us assume work. What work you want to assume? Because it is 10 and 20, I can take up any number which is a multiple of both. Yes. When we were doing it previously, we assumed work was 100 boxes. So I'm continuing with that so that the explanation can continue. If work done is 100 boxes, what is the efficiency of Aryan?
10 per day,
10 per day.
And efficiency of Piyush would be
5 per
5
day.
per day.
5 per day. Now let us come to the question. Aryan is working 3 days alone. So in these 3 days, Aryan will be completing
30.
30 boxes. I don't know how many days Aryan, Piyush, they are working together, but I know that Bimal completes only 10% of the job. What is 10% of 100?
10.
10. So if Bimal does 10 boxes, Aryan and Piyush together will do 90 boxes, out of which 30 are already done by Aryan alone, which means Aryan and Piyush together will be doing 60 boxes. Correct, everybody?
Yes, ma'am.
Now, Aryan and Piyush together, they are doing 15 boxes per day. So, to complete 60 boxes, how many days will be required? They are already doing 15 boxes per day. 15, 15, 15, 15. So, how many days are required?
4 days.
4 more days. So, now my question is, in how many days was the job done? What should be your answer?
7 days.
7 days. Right? 3 days that Aryan worked alone and 4 days that Aryan and Piyush worked together. Are we getting this? If there is any question, please feel free to ask. Okay,
Clear, ma'am.
moving ahead. A tank has an inlet pipe and an outlet pipe. If the outlet pipe is closed, the inlet pipe can fill the tank in 8 hours. And if the outlet pipe is open, Then the inlet pipe can fill the tank in 10 hours, which means inlet plus outlet pipe together can fill the tank in 10 hours. If only outlet pipe is open, in how many hours will the tank become half full? Okay. So first of all, 8 and 10, let's start with our steps. What is the work that you want to assume with these numbers?
40.
40. So let us say the tank is 40 liters in capacity. Okay. So if inlet pipe alone can fill the tank in 8 hours, it can fill how much per hour?
5 liters.
5 per hour. And along with the outlet pipe, it can inlet pipe can fill the tank in 10 hours, which means it can fill how much per hour?
4 liters.
4 per hour, which means outlet pipe must be removing 1 per hour. Do you understand this?
Yes.
Right? Because there is an outlet pipe also open, it takes more hours to fill. The reason being that outlet pipe must be removing 1 per hour. Now I am told if only outlet pipe is open, in how many hours the full tank will become half full. So out of 40 liters, if the tank has to be 20 liters, how many hours will it take for outlet pipe alone? So if outlet pipe alone has to drain out 20 liters out of a 40-liter tank,
20 hours.
outlet pipe will take 20 hours because outlet pipe can empty 1 liter per hour. Did we understand this?
Yes, ma'am.
All of us? Okay. Let's look at this. Amal can complete a job in 10 days. Vimal can complete a job in 8 days. And Amal plus Bimal plus Kamal can complete a job in 4 days. They are paid 1000 rupees as remuneration. If the amount is shared by them in proportion to the work done, what is Kamal's share? So first of all, I'll have to find out what is the number of days Kamal takes alone to finish the job. For that, let us start first with step 1, work. What is the work you want to assume?
40.
40. So let's say my work is to pack 40 boxes. So Amal will be packing,
4 per day.
Vimal will be packing,
5 per day.
5 per day, and all three together would be packing
10
10
per
per
day.
day.
10 per day, which means Kamal alone should be packing
1 per day.
1.
clear.
Yes, ma'am.
Now, if I have to distribute 1000 rupees to Amal, Bimal, and Kamal, in what ratio should I distribute?
4:5:1.
Correct. In the ratio of their efficiencies, it should be distributed. Where I want to find Kamal's share. So, Kamal's share would be 1/10 of 1000, which would be 100 rupees. All right. Moving ahead. A tank is fitted with pipes where some are filling pipes and the rest are draining pipes. All filling pipes, they fill at the same rate. So let us say all filling pipes, they fill at F per hour, and all draining pipes, they drain at D per hour. Okay. The empty tank gets completely filled in 6 hours when 6 filling dry pipes and 5 draining pipes are on, which means if 6 filling pipes are on, we know that one filling pipe fills F liters per hour. So 6 filling pipes will be filling 6 F liters per hour, and 5 draining pipes will be emptying 5D liters per hour. And this is happening for 6 hours and the tank is full. Do you understand what I just wrote?
Yes, ma'am.
Okay. But This time it becomes 60 hours when 5 filling and 6 draining pipes are on. So instead of 6, if there are 5 filling pipes and there are 6 draining pipes, and this continues for 60 hours, the tank is again full. So which means this work will be equal to this work. Do we understand this also?
Yes, ma'am.
Yes, ma'am.
Okay, so first let us try to solve and find the relation between F and D. What are we getting? Correct? I think we can further cancel this by 11 also.
Five, five, four.
Sorry, yeah. Right? So if because I have the ratio now, I can assume that filling pipe must be filling 5 liters per hour, while draining pipe must be draining 2 liters per hour. Did we understand this?
Yes, ma'am.
If I take my value of F as 5 and D as 4, I can also find my work by substituting these values on any one side of the equation. Let's say if I substitute on this side of the equation, what do I get my work as? 6 into 6 5s are 30 minus 5
Uh,
4s are 20, which will give me 600 liters, 60 liters as my work. Even if you substitute on the right hand side, you should get the same value of work. It should not change. Do we get this?
Yes, ma'am.
ma'am.
Now, what is asked? In how many hours will the empty tank get filled when one draining and two filling pipes are on? So, one draining pipe empties 4 liters and two filling pipes fills 10 liters. So, per hour, 6 liters is filled. So, to fill 60 liters, how many hours would be required?
10.
10 hours, and that should be your answer. All right. Okay. I'll give you a minute to try this question. Just excuse me for a minute. I think there's something I'll have to pay attention to. But you try this question. I'll be back in a minute and we'll solve together. So, yes, did we try? Anyone who
Yes,
would like
ma'am.
to take me through the initial steps?
Ma'am, the thing here is that the work done by A and B is not exactly given. So we are given with the timeline, so we can draw the timeline, but we have to assume the work done by both of them since B takes 25% more time than A.
Correct. B takes 25% more time. So first, because I'm seeing most of the things being talked about in percentage, I think we can first let's try to start by just assuming my total work to be 100. I don't know if this will work, but let's try what is said over here. Uh, B takes 25% more time than A, which means let's say if A takes X hours to finish the work, B will take 5/4
5,
of
5,
X
4,
hours to finish the work. Correct. And because, now again, I'll tell you one more thing, time taken is always inversely proportional to efficiency of the people. So more the time, lesser the efficiency, lesser the time, more the efficiency. So if time taken is 25% more, which means A has to be 25% more efficient than B. Do you understand this?
Yes.
Okay. So for example, in terms of efficiency if B's efficiency is Y per hour, A's efficiency has to be 5 by 4 of Y per hour. Okay, now let us try to see the question. They two finished the job in 13 days in the following manner. So total time taken is 13 days. A works alone till half the job is done. So A is working alone till 50 units of work is done. Correct? Because it is told 100 units. Then A and B, they work together for 4 days. 1, 2, 3, and 4. And finally, B works alone to complete the remaining 5% of the job. What is 5% of the job? 5 units,
5.
right? And here A has completed 50 units up till here, which means 55 units are done like this, right? So how many units are left over here?
45.
45 units are left. Now, when A and B are working together, can I say that they are doing 5 by 4 Y plus Y units per hour? I mean, here in terms of days, sorry, because your question is in terms of days, your entire efficiency and time will be in terms of days. Okay, right? So, yeah, 5 by 4 Y plus Y will give you what? 9Y by 4 units of work is done by per day. Now they are working together for 4 days. So can I say the total work done by them together is 9Y by 4 into 4, and which is equal to 45 boxes. So Y is nothing but 5. So now Y was nothing but efficiency of B that we had assumed. What is the question asked? In how many days can B finish the work alone? So if B can pack 5 boxes per day, to pack 100 boxes alone, how many days will B take?
20.
20 days. It's an important, good question. See, if you just go step by step, it is time and work is one such chapter where most of the questions are quite manageable. You just have to be little careful going step by step because a lot of variations are also possible at the same time. But if you see in each and every question that we have solved up till now, more or less we have followed the same system. If you get a hang of that, it should not be a problem. All right. Um, Moving further, we have finished time and work as a topic. Again, just repeating, please try solving questions, more and more questions from all the topics from other sources as well. And I'll leave that up to you, and you can, of course, come back to me with any doubts that you have regarding it. And today, now we'll be starting with new topic, which is time, speed, and distance. Let us try to cover first the entire conceptual part of the chapter, and then as and when the if the time permits, we'll be doing the remaining, I mean the questions part. So there are a lot of different concepts existing with time, speed, distance. So let us first try to do that. Time, speed, distance, part 1. So first of all, how do I relate these three variables? How do I relate time, speed, and distance? Speed is equal to
Distance upon time.
distance upon time. In case you ever forget or you get confused, you can always think of the speedometer that you have on any vehicle that you must be driving. Speedometer always gives you your speed in kilometers per hour. So kilometer is distance, hour is time, kilometers per hour is the speed, So speed is distance upon time. Okay. So when I say speed is distance upon time, again in time speed distance, this is the only equation that we will be using throughout, where in most of the cases, two things will be given, the third will be missing, right? One major thing that you will be expected to be careful about are the units. So if speed is in kilometers per hour, distance is in meters, time is in seconds, you can't just put those numbers directly. You will have to get everything in one single unit, and then you will have to use the numbers. So with this basics, just let's start understanding the concept. So we know that speed is nothing but distance upon time. So whenever time is constant, which means if time taken in two different situations is constant, I can say that speed and time are directly proportional to each other. More the speed, more the, sorry, speed and distance are directly proportional to each other. More the speed, more the distance covered, less the speed, less the distance covered, of course provided that the time taken is constant. Similarly, if distance is constant, distance to be traveled is constant, I can say that speed and time are inversely proportional to each other. More the speed, lesser the time taken, and lesser the speed, more the time taken to cover the same distance. Okay. So, basic question, if speed of two cars is in the ratio 3 is to 4, then the distance covered by them in the same time will be in what ratio? So if time is constant, I know that speed and distance are directly proportional. So if the ratio of speed is 3 is to 4, the ratio of distance should also be
3:4.
3 is to 4, because both these things are directly proportional to each other. So the ratio has to remain same. And if the condition is the distance is same, and if the speed is in the ratio 3 is to 4, what should be the ratio of time?
4:3.
4 is to 3, because they are inversely proportional. Do we understand this? Okay.
Yes, ma'am.
Yes, ma'am.
Now the next, if the distance is same again, and the ratio of speed is given to you as 3 is to 4 is to 5, what should be the ratio of time taken? See, when there are only two numbers in the ratio, you just directly invert the ratio. But here there are three numbers in the ratio. 1 is to 3, 3 is to 4 is to 5. So generally, if speed, the ratio is 3 is to 4 is to 5, time, the ratio actually becomes, because time and speed are inversely proportional, 1 is to 3 is to 1 is to 4 is to 1 is to 5. In this case also, time ratio was actually 1 is to 3 is to 1 is to 4, but when you cross multiply, you get 4 is to 3. Now here there are three numbers, so to simplify this, I will first have to take LCM of denominators. What would be the LCM of denominators?
60.
60.
60. So basically, if I have to write in terms of numerator denominator, it is 20 is to 60, 15 is to 60, and 12 is to 60. So basically the ratio of time taken is going to be 20 is to 15 is to 12. All right, moving ahead. Next that we need to understand is conversion. So as I said before, that in this chapter you have to be careful about the units. So if I have to directly convert speed from kilometers per hour to meters per second, you just need to multiply the number by 5 by 18. That is the factor, right? And if I want to convert the speed from meter per second to kilometers per hour, you need to multiply the same speed by 18 by 5. So basically your 36 kilometers per hour is equal to 36 into 5 by 18 which is 10 meter per second. So if rest of the things are given in meters and seconds, I can directly use this conversion for the speed. So these two conversions are important. Please take a note of them. 1 mile per hour. So I think this will have to be, say, generally in terms of miles, they give you, they give the conversion. They are never asked. I'm not very sure about it. I'll have to check. 1 mile is equivalent to how many kilometers? Just give me a second. You hardly will be using this, but still, we should know it's 1.6. So 1 mile per hour is nothing but 1.6 kilometers per hour. Because here the hour thing has not changed, we just need to convert 1 mile into 1 kilometer. So this was the concept. What we did up till now is the relations between these three variables taken individually as well. Now we will talk about the concept of average speed. So in any condition, average speed is always calculated as total distance upon total time taken. Average speed is never average of speeds. So for example, if I tell you that, let's say, from home to office, okay, I am going with a speed of 40 kilometers per hour, and I am coming back with a speed of 60 kilometers per hour. What will be the average speed of my journey? You might say 40 plus 60, 100 by 250. 50 would not be your answer because you cannot directly take the average of speeds. So now how would you do it? Total distance upon total time. So if I consider my total distance to be, my distance from home to office to be d, what will be my total distance for the entire journey? 2d. Now
Yes.
time taken from going from home to office. If I'm traveling at a distance t at a speed of 40, what will be the time taken? T upon 40 plus time taken to come back will be d upon 60. So if you take out d common from numerator and denominator, it totally gets cancelled. If you take the LCM of denominators below, that comes up. So 40 into 60 upon 40 plus 60 is 100, which gives you 48 kilometers per hour as the average speed. In case you have not understood anything in this entire calculation, please ask before I move forward. So this is how average speed will always be calculated. Now, distance different, speed different. So in that case, let us try to look at this. A person covers 170 kilometers of his journey at a speed of 34, next 270 kilometers at a speed of 45, and last 360 kilometers at a speed of 40. What will be the average speed? So how will I calculate average speed? Again, total distance. What will be the total distance in this case? So what is the total coming down to?
800.
170 plus 270 plus 360 is 800. That is total distance. And now total time. So in the first 170, if the speed is 34, what is the time taken for this first part of the journey? 170 upon 34 would be
5.
5 hours. Time taken for the second part of the journey? 270 upon 45.
6 hours.
And time taken for the last part of the journey?
9 hours.
So 800 upon 20 would give you
40 kilometers per hour.
So that would be the average speed of the journey. So in the journey, if distances are separate and the speeds are separate, you will have to calculate with this traditional method of total distance upon total time. Okay. Next case. So here we are getting introduced to different cases when it comes to calculation of average speed. Second case is when the distance is constant, right? So the distance is same. In the case that we saw above, if you saw your home to office, the distance did not change. So in that case, if there are three different stretches for the same lengths and the speeds are different, how do I calculate average speed? If you observed over here, we calculated what was the final that we got for the average speed, 2ab upon a plus b. So in this case, when distance is constant, the average speed is always the harmonic mean of speeds given to me. How do I calculate harmonic mean of speeds here? So because in this case, I'm going to have 30, 60, 93 speeds. Same case, I'll have to do 3 upon 1 by 30 plus 1 by 60 plus 1 by 90. We had introduced harmonic mean in the chapter of averages. So whenever distance is constant, average speed is always harmonic mean of speeds. In the above example, we did with 2 numbers. In this example, we are doing with 3 numbers. So I'll have to calculate this. Now in this case, if I take the LCM of denominators, it's going to be 180.
180.
Correct? So 3, 6, this is plus 3, plus 2, and your main numerator is 3. So 3 into 180 is 540. 540 upon 11 is your average speed. Are we getting this?
Yes, ma'am.
Now, if we have one more variation where speed is different and time is also different, then how do you calculate average speed? Again, so average speed is total distance upon total time. So in the first case, when 2 hours of journey is conducted with a speed of 30, what would be the distance of the first part?
60 kilometers.
60 kilometers. Distance of the second part would be?
120 kilometers.
Correct. And distance of the third part would be?
250 kilometers.
250. And the total time taken for the entire journey would be?
10 hours.
10 hours, right? Which means your average speed is going to be 120, 60 is 180, 430 upon 10, 43 kilometers per hour. Did we understand this?
Yes, ma'am.
So here again, there is no shortcut. Okay. One more variation, if time is constant, which means a person covers a particular journey at 3 different speeds, each for equal intervals of time. If time is constant, average speed is directly arithmetic mean of speeds. Arithmetic's mean is nothing but simple average. So if I directly take 30 plus 60 plus 90 divided by 3, which is going to be nothing but 60 kilometers per hour. So two special cases, if distance is constant, average speed is the harmonic mean of speeds. And if time is constant, average speed is the arithmetic mean of speeds. If there's any question up till here, please ask. This is important. All right, then, moving ahead. time after meeting and reaching opposite ends. Again, this is a special case. We will be using these cases in questions, and that is when you'll understand better. But still, let me explain the case. If two people, they start from 2 points A and B. So let's say a person A is starting from A, there's a person starting from B. They are moving towards each other, and let's say they are meeting at some point C. Okay, after they meet at some points, they reach the opposite ends. So A will take A hours to complete the remaining part, and B will take B hours to complete the remaining part of the journey, right? So if they are taking A and B hours respectively to finish, I can say that speed of A upon speed of B will be equal to the ratio of time taken by B upon time taken by A, or in fact, I would not write like this, B hours upon A hours per square root. I need you to understand this condition or situation very clearly. If two people are traveling from two opposite ends towards each other, and after meeting at a certain point, the time taken to finish the remaining part of the journey by each one of them is given to you, then your speed by A upon speed of B is equal to square root of, be careful, the time taken is inverse, time taken by B to complete the remaining journey upon time taken by A to complete the remaining journey. Again, this is a special case, as I told you. So once we use it in the question, that's going to be more specifically clear to you. But as of now, did we understand the situation? When is this to be used?
Yes, ma'am.
All right, let's move further. Okay, so we did the concept of average speed. Now the next concept, which is very, very important and very interesting, is relative speed. Okay, so what do I mean by relative speed in general? So, first thing first, relative speed is never the actual speed of any object. Relative speed is a concept of speed. It is what you feel, but it is never the actual speed. So, for example, if you are walking on a road and a fast car goes by you, you will feel a certain speed of the car that is very fast compared to your walking speed. Now a second situation, let's say you are also driving a car on road at a normal speed and a fast car goes by you. Now the impact of that fast car's speed that you will feel would be lesser. The speed of the fast car has been same in both the cases, but your speed has changed. In the first case, you were walking. In the second case, you were also driving with a considerably normal speed, right? So because you were already in your at your particular speed, the impact of the faster car in the second case would be lesser than in the first case, because relatively that is less faster. Do you understand this?
Yes, ma'am.
Okay, so
Yes,
we
ma'am.
are going to look at the concept of relative speed. Don't worry, it is very simple. If I have two bodies moving in the same direction. Okay, now for the concept of relative speed, before going with the slides, let me try to explain the concept with a small story. Okay, then we'll go with the theory part. Let us go with the small story. So, uh, let's take interesting characters in the story. Let's say Romeo and Juliet. Okay. Now I want you guys to keep on answering questions when I ask, and you will learn the concepts by yourself. Fine. Let's say Romeo's speed is 15 kilometers per hour. Okay. And Juliet's speed is 10 kilometers per hour. Okay. Now they both are distanced from each other by 100 kilometers. These are all the facts and figures given to you. Now, my first question. If Romeo and Juliet, they both want to meet somewhere between, and they both leave from their respective houses at the same time, after how much time and where will they meet? You can take a minute, you can tell me the answer by common sense. There are multiple ways to answer this question, and you have already learned how to do that. Okay, tell me one thing, will you meet closer to Romeo's house or Juliet's house?
Juliet's house.
Why so?
Because Romeo is traveling at a faster speed, so he'll be able to cover more distance than Juliet.
Okay, let's say they are meeting here. Okay, so now tell me one thing. For Romeo to reach from his house to this point, and Juliet to reach from from her house to this point, would they take same time?
Yes, the
So
time
when
will
I
be
say
same.
in this is the case where time is constant. So if you remember the first slide that we did, whenever time is constant, what is the relationship between speed and distance?
Directly proportional.
Correct. So what is the ratio of speed given to you over here?
3:2.
So the ratio of distance covered by Romeo and Juliet respectively should also be 3:2. Agreed? So from a
Yes.
total of 100 kilometers, if the distance has to be distributed in the ratio 3:2, what is the distance covered by Romeo?
60 kilometers.
And what is the distance covered by Juliet?
40 kilometers.
So where will they meet? 60 kilometers from Romeo's place or 40 kilometers from Juliet's place? Okay. When will they meet? Now to cover 60 kilometers, how much time will Romeo take?
4 hours.
Or to cover 40 kilometers, how much time will Juliet take?
4 hours.
So they will meet after 4 hours. Did you understand this method?
Yes, ma'am.
So this is something we'd already done. That's why I said that you should know this.
Yes.
Now there is one more way of thinking. So I know that Romeo travels 15 kilometers every hour and Juliet travels 10 kilometers every hour. So in 1 hour, totally how much distance is covered? In 1 hour, Romeo will cover 15 from here and Juliet will cover 10 from here. So in 1 hour, totally how much distance is covered? Are we understanding this or no? See, there is a stretch of 100 kilometers. Now understand that Romeo and Juliet together with the combined effort have to cover that stretch. Now with Romeo's effort, he is able to cover 15 kilometers in 1 hour. And with Juliet's effort, she is able to cover 10 kilometers in 1 hour simultaneously. So which means in 1 hour, out of the entire stretch of 100 kilometers, can I say 25 kilometers are covered?
Yes, ma'am.
So now this is relative speed. I know that nobody's speed is 25. Neither Romeo is traveling by 25, neither Juliet is traveling by 10, but the effective speed that is applied per hour is 25 kilometers. That is the effect. That is not the actual speed of either of them. Do you understand this? So basically, whenever two objects are moving towards each other, the relative speed is nothing but the addition of two speeds. So if I apply this concept, relative speed is again relative distance upon time. So relative speed, because both the objects are moving towards each other, is 25 kilometers per hour. What is the relative distance? Distance is nothing but the distance to be covered by both of them when they start moving together. So the distance to be covered by both of them when they start moving together is 100 upon time taken. So time taken is nothing but 4 hours. Okay. Now let's do a variation in this question. Let's say same thing, Romeo still has a speed of 15, Juliet still has a speed of 10, and they both are still distant at 100 kilometers at 100 kilometers, sorry. Now, instead of moving towards Romeo, Juliet starts moving in this direction and Romeo starts following her. In how much time will they meet? So now let's try to understand what is happening. Again, because both are moving in the same direction, the relative distance that Romeo has to cover to meet Juliet is 100 kilometers. Do we understand this? He has to get 100 kilometers closer to Juliet. Now,
Yes, ma'am.
Juliet is covering 10 kilometers in 1 hour in this direction, and Romeo is covering 15 kilometers in 1 hour in the same direction behind her. So, Romeo will get how many kilometers closer to Juliet effectively in 1 hour?
5 kilometers.
5 kilometers. So that is your relative speed. So I'm putting one more condition here. If both the objects are following each other, your relative speed is the difference between the two speeds. So 15 minus 10, 5. Your relative speed is 5 kilometers per hour. The distance that Romeo actually has to cover is 100 upon time taken. So your time taken is going to be 20 hours in this case. We can also verify. In 20 hours, Juliet will cover how much distance? 200. And in 20 hours, Romeo will cover how much distance? 300. So clearly they both will meet because Romeo has covered 100 more. Okay. Let us take one more case. If Romeo again has a speed of 15 and Juliet again has a speed of 10, both are still distanced at 100 kilometers. Now instead of going towards Juliet, Romeo goes this side and Juliet follows him. Now when will they meet? So what would be the relative speed over here?
10 minus 15
Which is,
minus 5.
so can they ever
Uh,
meet?
no.
No.
The person who is following is slower, practically. They can never meet. Did we understand this?
Yes, ma'am.
All right then. Let me give you one more variation. Okay. So let's say again same data. Romeo 15 ka speed and Juliet has a speed of 10. Now what happens is they both decide to meet somewhere, but due to some reason, Juliet leaves from her house 2 hours late. So of course, Romeo is in this direction, Juliet is in this direction. They decide to meet somewhere midway, but Juliet leaves from her house 2 hours late. Now, when will they meet? Okay. So now what will happen in this case? So for the first 2 hours, what is happening?
Only Romeo is traveling.
Correct. So for first 2 hours, Romeo will be covering how many kilometers?
30.
30 kilometers will be covered. See, one more thing. The concept of relative speed comes into existence only when two or more objects are moving simultaneously. There is nothing like relative speed when only one object is moving. So when there is only Romeo walking for the first 2 hours, relative speed does not exist. Okay, so now Romeo has covered 30. Now Juliet has also started moving. So with Romeo and Juliet moving towards each other, what is the relative speed for the next part of the journey?
25 kilometers.
25. And what is the relative distance that is to be covered with this relative speed?
70.
70, and time taken will be 70 by 25 plus 2 hours that Romeo walked alone. So your total answer is going to be 2 plus 70 by 25 hours for them to meet. Did we understand this?
Yes, ma'am.
I'm going pretty slow because I want you to understand this first. Only then we will be able to, solve the questions out of this. Now, in this case, if I had changed the question a bit and I would have said that instead of Juliet, Romeo leaves from his house 2 hours late, then what would be your answer?
So the effect, so the relative speed will be 25, but the distance will change to 80 kilometers.
So what would be your final answer? Correct. What you said was absolutely.
130 by 25?
So basically 2 plus 80 by 25, right? I'm not going to the
Yes.
simplification. But if Romeo is 2 hours late, instead of this, your answer will be 2 plus 80 by 25. If anybody of you has not got this, please don't feel hesitated to say, I'll explain again. Not a problem. Are we clear?
Yes, ma'am.
Now let me give you one more variation. Okay. Let's say they both decided to meet, same case, and in this case, they both leave on time. So they both um they left on time. Okay. But after 1 hour, Romeo realizes that he forgot his wallet home. Okay. So after 1 hour, Romeo realizes that he forgot his wallet home. So he goes back home, collects his wallet, and again starts moving towards Juliet. So in this case, now, when will they meet?
Juliet has already covered 10 kilometers in the meantime. So now, will it be 1 plus 90 by 25?
No. Will Juliet have covered only 10 kilometers in the meantime? Think about it. What is happening?
Okay,
They,
so there's a 2 hour difference.
correct.
Okay, okay, got
So
it.
when Romeo restarts, Juliet has already covered 2 hours.
So 20 kilometers is already covered.
Correct. It's the same answer. So Romeo, after 1 hour, going back and starting again is equal to Romeo being 2 hours late. Do you understand this? Logically, Romeo is 2 hours late.
Yes, got it.
So the answer is going to be same, 2 plus 80 by 25.
Yes, ma'am.
Okay. Now last variation in this set, and I'm not going to help you there. You're going to tell me the answer. So pay attention. Um, okay. Again, Romeo with a speed of 15, Juliet with a speed of 10. Um, they are distance at a speed at a 100-kilometer stretch. And I'm going to introduce one more character in this love story, necessarily, of course, a villain, Juliet's dad. Okay, whose speed is 25 kilometers per hour. That's fast. Okay, now let's listen to the question very carefully. So Romeo and Juliet, they both decide to meet somewhere midway. They both leave on time and they meet at the desired location. As soon as they meet, they realize that Juliet's dad is aware of their affair and he starts following. So let's say they meet here. So as soon as they meet, they know that Juliet's dad is aware of their affair and he starts following them. So of course, they will try to run away from him, and Juliet's dad is following them with a speed of 25. So when and where will he catch hold of them? Take a minute if you want, but I want you to try this. It's interesting. So tell me when leave Juliet's dad right now out of picture. Where will Romeo Juliet meet?
After 4 hours,
Okay, at what position?
60 kilometers from Romeo and 40 from Juliet.
Right? So they are going to meet like here 60, 40. Okay. I'm so sorry. I forgot to give you one information. I'm so sorry. Juliet's dad is distanced at 50 kilometers from Juliet's house. Sorry, my fault. Okay. So they'll meet at 60-40. Now they are meeting at this point, let's say, right? Now, as soon as they come to know about Juliet's dad, of course, they'll start moving in this direction, and Juliet's dad will start following them in this direction. So, what is the now there are two objects moving simultaneously. So, of course, the concept of relative speed will exist. What is the relative distance between the couple and Juliet's dad?
90 kilometers.
90. And what is the relative speed between the couple and Juliet's dad?
25 and 10.
So Romeo and Juliet together as a couple will run with what speed? 15, 10 or 12.5?
Why 12.5?
No, I'm not saying 12.5. So that I took an average of 15 and 10. I'm asking you which of the three is the correct answer. Is it 15, is it 10 or is it 12.5? For couples. I mean for just Romeo and Juliet to run together, because they'll be now running together towards Romeo's house. At what speed will the couple be running is my question.
I think the average speed.
So in a practical situation, if one of the pair is slower and one of the pair of person is faster, and if they have to run together, at what speed can both of them run? The faster speed, the slower speed, or the average speed?
The average.
So Juliet, you think can run at 12.5? So whenever two people are
Uh,
running
do we
together,
take the relative speed of
no,
running in
no,
the same
relative speed
direction?
we'll take later. Right now, I'm considered about the speed. When after meeting, at what speed will they both run together? First, I'll have to know that, right?
Yes.
So whenever two people are running together, they can run together only at slower speed. I mean, Romeo can run at 10, but Juliet can't run at 15 or 12.5. Do you understand this? और ये उस जमाने का
Got
रोमियो है, मतलब वो ऐसे ही छोड़ के भाग नहीं जाएगा. He's going to take his Juliet along, right? Jokes apart. So both will run together at a speed of 10. Juliet's dad is following them at a speed of 25. That is why the relative speed between them is going to be 15. Do you understand this?
Got it.
So time taken for all three of them to meet is going to be 6 hours. Right? We can also see where they can meet. So if I say Romeo Juliet at a speed of 10, if they are running for 6 hours, they will cover 60 kilometers and they will reach Romeo's house. Juliet's dad with a speed of 25, if runs for 6 hours, he will cover 150 kilometers and he will also reach Romeo's house. They're going to have a family meeting at Romeo's house.
Got it, ma'am.
So this is all about relative speed. If you understood this story well, you can solve all questions related to relative speed. So if you want to write down something, I'll leave the screen. And if you're done with it, let me know, because as soon as I go ahead, this data will be gone. So just a quick revision of what we did. If two bodies are moving in the same direction, what is the relative speed?
S1 minus S2.
Would be S1 minus S2, and opposite direction would be
S1 plus
S1
S2.
plus S2.
correct. Now again, the opposite direction has to be this and not this. Let's try this question. A drive from Mumbai to Delhi, which is 1500 kilometers apart. A drives, sorry, from Mumbai to Delhi at a speed of 50. At the same time, B starts from Delhi to Mumbai at a speed of 150. When will they meet? What happened? It's the simplest of the questions. Let's say here it's Mumbai and here is Delhi. The distance between Mumbai and Delhi is 1500 kilometers. A drives from Mumbai to Delhi at a speed of 50 kilometers per hour. and B drives from Delhi towards Mumbai at a speed of 150 kilometers per hour. When will they meet? So what will be the relative speed between them? Am I
200.
audible? 200. And what is the relative distance to be covered by them? Your relative speed is 200. What is the distance to be covered by both of them?
1500.
1500 upon time taken. So what will be the time taken for them to meet?
7.5 hours.
7.5 hours would be correct. Are we all getting this? I'm a little scared why you couldn't answer this question. Okay, let's look at this. Had they started at 11 a.m. from their respected places, at what time will they cross each other? What should be the answer to this?
6:30 p.m.
30 p.m. Because 7.5 hours is after they start moving together, which is at 11 a.m. So 6:30 p.m. is when they will meet. Now let us look at this. A drives from Mumbai to Delhi. Again, Mumbai, Delhi. But certain situation has changed. Let's look at the change situation. And I really want you guys to answer this. Mumbai again, Delhi, 1500 kilometers apart. Now A starts from Mumbai at a speed of 50 and B starts from Delhi at a speed of 150. But the situation is A starts at 6 a.m. and B starts at 12 noon. That's 12 p.m. At what time of the day will they cross each other? So here what will we do? All these questions are similar
So
to Romeo Juliet story. Yes, yes, tell me.
A has already covered 180 kilometers.
How?
1500 by 50.
Why 1500 by 50? And that would be 30. But why so?
Yes.
Can you tell me it is which case of Romeo Juliet story that we did?
Where Juliet starts late.
Correct. Right? So in that case, what did we do? See, to apply relative speed, both of them have to be moving. Your A and B, they are not moving at the same time. So what will we do first before applying relative speed? Who is moving first?
Sorry. So A will travel for 300 kilometers in the 6 hours.
Correct. So for the first 6 hours till 12 p.m., A will already cover 300 kilometers. So now the distance between them is 1200 kilometers. And now both are moving towards each other. Did we understand this, girls?
Ma'am, can you just explain the 300 once more?
See, A has started moving at 6 a.m. and B
Yes,
will
ma'am.
start moving at 12 p.m. So from 6 a.m. to 12 p.m., that is 6 hours, A is going to move alone.
Yes, ma'am.
Now, speed of A is 50 kilometers per hour. So in
Oh,
6,
so then 6 5s are 30. Okay, got it, ma'am.
right, A will cover 300 kilometers. So now the remaining 1200 kilometers has to be covered by both of them alone. So how much time will they take? Distance is 1200 kilometers. Relative speed is still 200 kilometers. So they will take how much time? 6
6 hours.
hours to meet in the second part. Are we
Got
first
it.
clear with this?
Yes, ma'am.
Now they
Yes.
are asked at what time will they meet? So this 6 hours is after they started moving together.
6 p.m.
Correct. So after 12 p.m., if I have to count 6 hours, they will meet each other at 6 p.m. Are we
Got
clear?
it, ma'am.
So again, I'm repeating in relative speed, if one object has started moving before the other object, make that object move first, eliminate that much distance, and then apply the concept of relative speed. Okay, and there is one more variation below. A drives at a speed of 50 again, starts at 6, and B drives at a speed of 150 from Mumbai to Delhi, and B starts at 10. At what time will they meet? See, I'm drawing the figure here, but I want you to answer. So again, Mumbai to Delhi, 1500 kilometers. A starts with a speed of 50 kilometers at 6 a.m. And B also starts from Mumbai to Delhi. That is the catch over here. B is also going in the same direction at a speed of 150 kilometers, but B starts at 10 a.m. When will they cross each other?
A has traveled for 200 kilometers in those 4 hours.
Correct. So I will first make A travel. So now A has reached here. Now A is moving this side and B is also moving this side at 10 a.m. So what is the relative speed between them?
100,
100. And what is the relative distance between them?
1300.
Relative distance is the distance between A and B when they start moving together.
Okay, so 1300 is for A and for B it's 1500.
No. Do you remember Romeo Juliet case when Juliet was going towards this direction and Romeo was following her?
Yes,
So what was the relative distance we took in that case? The distance between Romeo and Juliet when they started moving together, which was 100 kilometers.
yes,
So in this case, when A and B start moving together, the distance that B has to cover more to catch up with A is 200. So relative speed is 100, relative distance is 200 upon time taken. So basically, B will or B will cross A after 2 hours.
correct.
And this 2 hours is after what time? 10 a.m.
After
Because
10 a.m.
correct. So at what time of the day will they cross each other?
12, no?
Well, okay, this is one small concept that we'll do before we end the session because it is very, very closely related to relative speed, right? Same concept. Now, if we have trains added to the concept, what happens? For that, let's say if I have, I'm just going to use the some objects to explain this. Now, let's say this is train. Now, the train, generally for trains, you will be given two pieces of information. One is the speed of the train, and second is the length of the train. Okay, so let's say this is the train, and this is an electric pole in between. Okay. Now, if I ask a question, I hope everybody can see my face on the screen. You can see, right?
Yes, ma'am.
Okay. So if I ask a question, how much time will this train take to pass the pole completely? So when I say pass the pole, the time taken to pass the pole starts at this moment and it ends at this moment. So in that case, to find this time, what speed and distance will you consider?
Distance will be the length of the train and speed will be the speed at which the train is traveling.
Correct. So this is the first case. If there is a train and an object with a negligible width, a person, a pole, a stick, anything like that, distance is going to be the length of the train and speed is going to be the speed of the train. Are we clear with this? Now, instead of, so can you see this object on the screen?
Yes,
Okay.
ma'am.
Let's say this is the platform. Okay. So now my same question, how much time will train take to cross the platform? So of course, time taken to cross the platform will start at this moment and will end at this moment. So in this case, if I have to find the time, what will be the speed considered?
The
Speed
speed
of,
of the train,
but what will be the distance considered?
length of the train and the platform.
Very good. So the distance considered will be length of the train plus length of the object, and speed will be only speed of the train. Did we understand this?
Yes, ma'am.
Now, when the other object is moving, right? So let's say instead of electric pole, now there is a man who is moving with a certain speed. In that case, again, distance will be still length of the train only. Because even if the, let's say if my finger is a man, even if the man is moving with a certain speed, time taken to cross the man will be when train starts and train ends crossing the man. The distance is still length of the train. But what will be the speed in this case? What will be the speed taken in this case when the object is also moving?
The relative speed.
Correct. It would be the relative speed, either addition of both the speeds or subtraction of both the speeds, depending on the direction. And now,
Yes,
Yes,
ma'am.
ma'am.
same case with object of substantial width, like another train. So in that case, again, I will have to take the length of object plus length of train. So both the trains or whatever the second object is and the speed will still be relative speed because both the things are moving. So what I'll do is we'll stop the concepts here. There are two more things of boats and streams and races as concepts to be done, but we will not do it today. That would be too much for you to grasp. All
Thank you.
right. Thank
Thank you,
you.
ma'am.
Thank you so much. Thank you.
Thank you, ma'am.